at Glendale Community College. We are in Chapter 14 talking about intermolecular forces. This is our third video, and this is a summary of what we've learned so far. We're going to talk about bonds versus forces. Now, bonds hold atoms together. Ionic bonds are between a metal and a nonmetal. The metals are positively charged ions, the nonmetals are negatively charged ions, and opposites attract, so they are held together in an ionic bond. Then we have covalent bonds that can be polar or nonpolar. Covalent bonds are between nonmetals only, just nonmetals. Now, if they're different nonmetals, then the electrons are shared unequally between the two nonmetal atoms. The one that pulls the electrons closer is closer to fluorine, and so it's negatively charged, a little bit negative, delta minus. The other atom is delta plus. So the molecule has a minus and a plus end, so it has poles like a magnet, polar bond. Nonpolar covalent bonds are when you're bonded to yourself, like C to C or O to O. CH bonds are also nonpolar. Now the electrons are shared equally in between the two atoms, so there's no poles, nonpolar. So those are your bonds. Now forces, there's 4 of them, they hold molecules together. The weakest force is London dispersion forces, which is for nonpolar molecules. Then we have a little bit stronger dipole-dipole forces, which are for polar molecules. Stronger still is the hydrogen bonding force, which is not a bond. It is named because you have to have a hydrogen bond to an inner O or F in the molecule. If you have a hydrogen bonded to an inner O or F in a molecule, it can hydrogen bond with other molecules, and that is a force. It's an attraction, so it's a force, not a real bond. The last and strongest force is ion dipole force. You have to have an ion with a polar molecule. So this would be all of our soluble ionic compounds in water, because water is very polar. Remember that, water is very polar. So if you have a soluble ionic compound in water, you will have ion dipole force. So we're ready for some questions now. We have 5 molecules, and we're going to determine if they're polar or nonpolar first, and then figure out what force goes with them. The first molecule is CO2. Now, how do we determine if something is polar or nonpolar? Well, this goes back all the way to Chapter 7 when we do Lewis dot structures. Carbon's in the middle, and the carbon is actually double bonded to an O on the right side and double bonded to an O on its left side. It's linear with carbon in the middle. So we have 2 equal and opposite bonds that are polar. So we have 2 equal and opposite polar bonds. So the whole thing is nonpolar. So CO2 is a nonpolar molecule, and we determine that by doing a Lewis dot structure. What force goes with nonpolar molecules? You're right if you said London dispersion force, good job. So a nonpolar molecule, the strongest force it can have is London dispersion force. Next up is PF3. Now if we draw the Lewis dot structure for PF3, you'll see we have a P atom in the middle with a lone pair on top of it and 3 fluorine bonds, single bonds, pointing downwards. It makes a trigonal pyramid, little trigonal pyramid. So the PF bond is very polar. Fluorine is closest to fluorine, so it pulls those electrons close, and we have 3 arrows pointing down. Now those arrows are not equal and opposite, so they don't cancel out. So PF3 overall is polar. What force goes with polar molecules? You're correct if you said dipole-dipole force. Good job. The next example is HF. Now this is just one bond in the molecule, an H bonded to an F. Who's closer to fluorine? The F is. So F is a little minus, H is a little plus, and so is that polar or nonpolar? You're correct if you said polar. So we didn't even have to do a Lewis dot structure for that because it's just the one bond and it's a polar bond. Now, this is an H bonded to an F. Does that ring a bell? It should. Remember, if we have an H bonded to an N or O or F, we can do hydrogen bonding force. Yeah, hydrogen bonding force. We'll go with HF. The fourth example over here is CH4. That's a hydrocarbon. It only has CC bonds. So if you're bonded to yourself, you are nonpolar. And it has some CH bonds. CH bonds are nonpolar as well. So anytime you have a hydrocarbon, it's nonpolar. You don't have to do the Lewis dot structure. Don't waste your time. CH compounds are always nonpolar. And what's the strongest force that goes with nonpolar? You're correct if you said London dispersion forces. Now the last example is potassium iodide aqueous, meaning potassium iodide is in a beaker of water. So we have water and we have Ki in there. Now Ki is soluble according to rule number 1. Potassium compounds are soluble. So we have K plus ions and I minus ions floating around in the water. What force is going to go with that? We have ions in polar water. You're correct if you said the ion dipole force, the strongest force. Good job. Be prepared to answer more questions like these on exams and quizzes. Next up is Coulomb's law. Now, you may have heard of Coulomb's law if you had a physics course, but otherwise probably not. So basically it just says opposites attract. So opposite ends of a magnet attract. So positive to minus attracts. Opposites attract. And it says same charges repel. So negative to negative will repel and push away. Positive and positives will also repel and push away. And we'll save these questions for the next video. I hope you come back. The next questions are fun. It's like a game. So see you then. Bye-bye.